Germany and India and everywhere, people are talked called water splitting reaction. What is called water splitting reaction? So splitting the water into H2 and O2, because water is there actually available, natural rainwater, water is coming from that sea water, lot of water is there available in the earth. But drinking water is a problematic one. We are unable to get much drinking water. However, fuel is scarcity of the fuel is more there around the world. So everywhere we are not getting petrochemical fossil fuel. So people want to have alternative sources. So the research level splitting of water is going on. One of the scientists working in India actually is me. So I am also working on the splitting of water, how to split water into hydrogen and oxygen. So which is uphill reaction, I call it, because if you see that O2 to H2O, the reaction actually E value will be 1 point plus 1.23 volt. Yesterday I gave this homework. If you solve that, you will get a value plus 1.23 volt. If you see that plus 1.23 volt O2 to H2O, then if you want to break H2O to O2, that is not spontaneous reaction. That will be minus 1.23. So how scientists are doing water splitting? So I'm telling on the literature examples, as well as I am also working in this field. So I know it is uphill reaction. For such a reaction to happen, we need to have external forces. So like a catalysis. So we have to add a suitable catalyst to break water. That is the phenomena called water splitting. Why we are splitting water? O2 is actually one of the fuel in industry. H2 is one of the easiest fuel alternate to the any other hydrocarbon, fossil fuel. So this is what the scientists around the world. It started the early 1980s, 90s in Japan. Japan scientists used to do using a catalyst. We know the catalyst, Wilkinson catalyst, like that, rhodium containing catalyst, but scientists uses ruthenium containing catalyst for breaking the water. So nowadays people are working using electrochemistry to split water to capture energy. So the energy is nothing but fuel. Hydrogen is a fuel. So this is for your knowledge purpose I am sharing, which is not in your syllabus. But you should know conversion of O2 to H2O is E equal to positive value plus 1.23. But the reverse reaction is difficult. That much you should know. Okay. So now let us see what is the opposite terminology. Proportionation. One is disproportionation. I told like a decomposition. Proportionation is nothing but combination. Okay, you just remember COM coming from combination. So proportionation reaction means reverse of the disproportionation. Disproportionation reaction, just to look at that, one of the particular species is split into two different species, right, left hand side and right hand side. This is called a disproportionation reaction. Disproportionation reaction is nothing but one species is converted into two species. Here this one is the species which goes in two direction. Okay, so one is this species O2, another species H2O. So the middle species is split into two species. So this is disproportionation. Proportionation means two different species. You are seeing that two different species I have put. The two are actually getting combined and giving a one species. So this kind of reaction, I told that is what combination. So proportionation, you remember. So such kind of reactions should occur. The two species should form a single species. The E value is supposed to be positive. So this you have to remember. This example we can see from Frost diagram. So yesterday what diagram we have seen? Latimer diagram. So today we are seeing the diagram. The diagram name is called Frost diagram. Frost is the Arthur Frost. He is a electrochemist, so he invented this diagram. Arthur A. Frost, the name of the scientist. So the graphical illustration of stability of different oxidation states relative to its elemental form. That is relative to oxidation state 0. The diagram, what is the basic of this diagram? If I am conducting quiz program to all of you, the graphical illustration of stability of different oxidation states relative to its elemental form. You remember what is that elemental form? Elemental form is 0 oxidation state. So that is what the diagram. So first initially I want to tell you, you know delta G equal to minus NFE. So that equation I am rewriting. delta G equal to minus NFE. That is what you know earlier. We have used this equation in different places. Minus NF E. So now what we are rewriting is N and E we are keeping, the remaining portion is going delta G by F. Okay, so now this is what is the meaning that if you are having number of electrons participated in the reaction multiplied with this E value, because the couple, what is the redox potential required for the couple conversion from one form to another form. So this value multiplied value is equal to the free energy of the particular system. We can directly correlate with the free energy. So the Arthur Frost has used this. Instead of using small n, he has used capital N. Okay, so this is convention. We cannot do anything. Why he has used capital N? The logic is n is a small n is a number of electron. We call it number of electron involved in the process. If it is a 1 electron reduction or 2 electron reduction and all. So, but Arthur Frost used n is equal to the oxidation state of the system. That E value is corresponding to the, with respect to the original ground state oxidation state. I told you. Any other species he has considered with respect to its ground state oxidation state. So if you see, it will be a little confusing, but you remember Arthur Frost diagram. How he has written the diagram is N E naught in the y-axis, x-axis he has taken N oxidation state. That is what I have written here. N is the oxidation state he has taken instead of number of electron. So what is N now? What is the N is oxidation state means what it with respect to its zero state. Particularly any element you take from the zero state, the particular species. So this diagram we will draw. This diagram is nothing but why we are drawing this diagram. I told this diagram can immediately show about delta G. Delta G means the particular system is whether it is actually readily reactive or stable, this kind of information we can get. So Arthur Frost made this diagram as a handy reference, okay, system. Okay, now let us see the Ne proportional to the free energy. That is what he has taken. I told you N and E, why he has taken proportional to the free energy. N is the oxidation state relative to its elemental form. So if you take this, let us see how to draw the diagram taking two examples, then you will be able to understand. Let us take a Latimer diagram. If it is a descriptive type big question, you may be having this kind of challenge. A big Latimer diagram will be given to you. You have to convert the Latimer diagram into a Frost diagram. Here, what is this diagram? This diagram is a Latimer diagram. How we say Latimer diagram? The oxidation state you see N is +5. First, if the diagram will be given in exam or assignment or quiz, this oxidation state will not be given. You have to write the oxidation state of the, if I write nitrogen in acidic solution. So you have to note down nitrogen. I am talking about nitrogen. So you have to say nitrogen, what is the oxidation state? If I am writing chlorine in, if you are, I am writing chlorine in basic or acidic solution, you have to write the oxidation state of chlorine, not the oxygen. Sometimes you get actually perchlorate or something, but oxidation state of chlorine only you have to consider. Here oxygen and nitrogen is there. Oxidation state of nitrogen is written. That you have to remember. Nitrogen is +5 oxidation state in this case. Okay, in this case nitrogen in +5. Then it is +4. Okay, so we are considering that, and nitrogen here +3. So I am just putting the arrow to show. Otherwise you will get what I am talking. So nitrogen in acidic medium means oxidation state of nitrogen I am writing. Nitrogen N2 molecule, nitrogen is having 0 oxidation state. So that is what Arthur Frost want to do that. So every element he is comparing with N, that elemental state. That E value he want. He don't want is actually this actually the redox couple value of individuals as in the case of Latimer diagram. He don't want the Latimer diagram as such to be used. He want to use that the value of the oxidation state 5 to the oxidation state 0. What is the E value that he want? So that he will write it is a 5 electron process. This is the E value. So you will write N into E. So this is the significance. Arthur Frost want to do that. What is the E value for this conversion from N is +5 to N equal to 0. Like that he want to do N equal to 4, N equal to 4, then N equal to 0. What is that E value? So this E value he want first. This E05 I may write. So this E value E04 because fourth oxidation state I'm writing that. So like that he want to draw that oxidation state 3 to n equal to 0. So you want actually oxidation state value for third oxidation state to 0. Like that I write actually how many E. So these E values we have to calculate. We know well how to calculate the E value for non-adjacent potential. Earlier I have already taught you delta G equal to minus NFE. So we can calculate the E value, redox potential value. E value means redox potential value for non-adjacent member. Now you see this is not actually adjacent member. Okay, so n equal to plus 5 to 0. There are many members in between. So how to do this calculation? That is what we are going to learn. So how to do this is the implication Arthur Frost want to do. You want to identify E value for process E, this conversion A, then E value for conversion B, E value for conversion C. Like that I put an arrow, different color. You know that every species with correspond to the ground state or zero state. So after that the diagram extends because I don't have a space. I have to write after this n the diagram supposed to be extended like this. So we are having NH2. So that is what I put the arrow. This diagram is extended. So I am having NH3OH. So this is actually nitrogen is in -1 oxidation state. Here nitrogen in -2. Here nitrogen in ammonia -3 oxidation state. So this is what the diagram ends. However, what you are doing that you are getting the E value with respect to the particular oxidation state up to the your zero state. So that is what we are doing. So we have to do that, convert that with the reference. It's not converting plus 0 to 0. It is a redox potential required for the conversion between plus 5 to 0. So but never change the sign. So never change the arrow. Arrow should be always towards right hand side. You see that the arrow will end at the last towards the right hand side end terminal. See, here also see nitrogen to the 2 minus charge. So here also the arrow should end here. If nitrogen to 3 minus, the arrow should end at this location, which is nothing but right hand side. The arrow should not be reverted. Nobody should write the arrow towards this. So this is not suggested by Arthur Frost. Frost told left hand side to right hand side you draw any arrow and calculate the E value for the particular conversion. So this is what he want to do, the calculate that actually conversion for E value for each species. Each species means plus 5 का कितना है, plus 4, plus 3, plus 2, 0. Then actually he want to calculate for -1, -2 like that. Is all the possible oxidation state given in the Latimer diagram. So what is this diagram? This diagram is actually originally Latimer diagram only. You have to remember Latimer diagram only given. Okay. So now we are converting by calculating this. We want to get a Frost diagram. Frost diagram required 2 units. One is n E0 for x-axis, comma y-axis for, and n is the oxidation state of the particular species. Okay, with respect to the original zero state. So these two are required. This table you have to make Ne versus n. That is what we are calculating the E value for each state. Plus 5 to 0, what is E? Plus 4 to 0, what is E? Plus 3 to 0, what is the E value here? So plus 2 to 0, what is the E value? So everything we have to calculate. Plus 1 to 0, we know already the value is there. You don't need to calculate the next member. It already there written here. So again here it is there. Okay. 0 to -1 already the value is there. You don't need to calculate. But 0 to -2 we don't have. So it is like a non-adjacent potential we are calculating. 0 to 0 oxidation state to -3 we don't have. So this E value you have to calculate. So which are the things available? I circled in the above. So those things are available. So we have to write the oxidation state of each species and its n value. 5 plus 5 plus 4 plus 3 plus 2 plus 1. Then 0 oxidation state of -1 -2. So we have to write that n value versus Ne value. 0, why I am not writing 0 into E 0. So I don't want to write that. So now let us go how to calculate that. The equation is minus NFE equal to minus N1 E1. Why minus? Always I am multiplying my N1 E1 plus N2 E2 plus N3 E3. But in nature, it is a minus NFE. So all the minus symbols are there. You see that. Take out all the minus, it will be getting cancelled. So E equal to, finally it appears that what is that? E equal to N1 E1 plus N2 E2 plus N3 E3 by N1 plus N2 plus N3. If for example, I want to tell you for the particular case. This case is having, in this case easy, you know that only two species. This case is having how many species are there? There is one E, there is one E, three E's are there. From plus 3 this state to I am going for 0 state. So how to calculate the E value? So the E value I have to write E equal to N1 E1 plus N2 E2 plus N3 E3 by N1 plus N2 plus N3. If you write this, actually it is easy for you to understand what I am talking, because here N is a number of electrons, E is this value. So then N1 E1, so N2 E2, so N2 is plus 2, so N3. So in the bottom what you are writing, actually in the denominator and numerator, you just look at that here. N1 N2 N3 is nothing but plus 3 plus 2 plus 1, that much electrons. That means 1 electron, 2 electron, 3 electron. So finally you will get the E value for the particular corresponding E value for the conversion of plus 3 to 0, this E0C we will be getting using this equation. The similar way, how many N and how many E is there? So for this case you are having N, one N is there, one E. So second N2 E2, N3 E3, N4 E4, N5 E5. So 5 steps are required to get the E value of this A. A is a bigger series, right? So we need to write up to N equal, this equation will go dot dot, you write it N1 E1, N1 E2 like up to 5 system, N5 E5. So when you count that, actually you will be getting the E value for the particular system. Like that, if I am doing that, just if you see, it will go like this. Just a minute. Now you see the first system is A is plus 5 oxidation state. So plus 5 oxidation state I started to 0 oxidation state. Okay, so that is what the previous one. So one by one, if you solve this one, you will get a table. It is this question is simply making a table. Then you have to convert into graph. Here plus 5 oxidation state to, we are going for 0 oxidation state. Okay, so 5 electron process. So I am adding 5 electron. It is an acidic, so I am putting plus H, because we have to balance the, if they in the question it is asked that balance the reaction, then you have to balance and give the product, water will be formed. Okay, so here 3 oxygen is there, so 3 water molecule will be formed. So by writing 3 H2O, by solving the oxygen, we are end up with a shortfall of 6 hydrogen. So I write it 6 protons are involved, but it is a 5 plus 5 to 0, so 5 electron process. Why 5 I have written? Plus 5 state to 0 state it is converted, so 5 electron process. So this process E value calculated by E1, N1 E1, N1 E2, the formula, the previous one, this E value calculated for the system is actually 1.25. So what is the N value? So you write it E value comma N value. N value is plus 5. So N and E, now what do you have to calculate for this NE? So 5 multiplied by 1.25 versus plus 5. This is what you are going to plot in that. This is NE value in the y-axis. This is x-axis, like that. Here you see this is actually plus 4 oxidation state, 4 electron process, 0 we are getting. So that is what 0 to 4 electron process. Then we are solving this oxygen. So 4 O4 is there. Okay, so we are writing actually half into O4. So that is 2 oxygen. So 2 water molecule formed. So 4 protons we are writing. This is solving the equation. So like that you have to solve. It is very simple, solving based on the oxygen, number of oxygen in this side. Accordingly, put the remaining protons. Because nitrogen in acidic medium we are solving. Here it is a plus 3 oxidation state, 3 electron process. So with respect to this, now O2 become 2H2O because 2 oxygen, remaining 2 proton. Okay, so you are having 3 proton, 1 proton already here. So 3 proton, total 4 proton is required, the value. So now in this case, what happened? In this case, 4 multiplied by 1.36 to get Ne value. We need Ne value that is equal to, here Ne value equal to N into E. So 4 multiplied by 1.36 and plus 4. Like that you have to write here 3 multiplied by 1.45 volt plus 3 is the x-axis value. Like that you have to calculate this calculated value. You see A, B, C, D I have written here. All A is calculated, B is calculated, C is calculated. These all the things are calculated from the E value of each arrow towards the zero state. Okay, G up to H. So you can see that G and H up to that ammonia. The last one is ammonia. Formation of N2 to ammonia is the H. E0 value of H, that is actually ammonia, NH4 ammonium ion, not ammonia, ammonium ion. So this is actually N0 to ammonium ion formation, 3 electron process. This is -3, so 3 electron process. You are getting E0 is equal to 0.23. So like that here multiply by what you have to do that here this process actually is minus value. So here actually 3 into 2.727 and the oxidation state is -3. So you are multiplied by -3 oxidation state. So -3 multiplied by 0.27. This is what you have to do. If you write multiplied by +3, wrong value will come. After getting these values, we are going for this kind of table. That is what I did. You have seen that actually the last one I was talking -3 multiplied by 0.27 versus -3 in the x-axis. So we have drawn Ne and E. So this is what Arthur Frost want. The graph supposed to have a Ne versus N. Ne versus N. So this is the graph. So we have the values now. So this N is oxidation state. +5, +4, +3, +2, +1. Always write a sign. Otherwise, you may forget in exam. +5, +4 like that. Practice, better practice. This slide we made actually some 5-6 years back. Actually, when we made, we understand that actually people know without putting a sign. But actually, it is good to write a sign and write minus. We have to mention minus, plus we have to mention. In electrochemistry, using sign is always advisable. So if you write like this, Ne versus N. So then we will get the Frost diagram. How the diagram will appear. The diagram of nitrogen in acidic medium. That is very, very important. If it is not written, I am reminding you because I am talking the contest in acidic medium. So that you remember. Otherwise, actually it is difficult. Okay. In acidic medium, you have to write it. Otherwise, you will not remember. Easy to identify acidic medium. There is actually protonated forms are there. So protonated acids are there. So acidic medium, even I am not telling, you will understand that is acidic medium. Okay, what are the information you will get after drawing for all the oxidation state? Okay, up to the oxidation state +5, you are getting this value because you see that x-axis, the oxidation state 5 is the maximum oxidation state for that this species form. What is the Ne value? Ne will be slightly higher because 5 multiplied by 1 point something value. So you will get a +6.25 or something like that for HNO3. So this graph, what is the use of this Frost diagram? One of the important thing from the Frost diagram is you have to locate the nitrogen, you see. So nitrogen compound on this graph gives us stability relative to, okay, every compound, every species of nitrogen or every compound of the nitrogen and its stability with respect to the relatively to the our nitrogen molecule, N2 molecule. So what is the stability with respect to the N2 molecule? You know, N2 is very, very important species because nitrogen is present in atmosphere very huge amount. You know what is the percentage? About 78% of nitrogen is there in the atmosphere. That is what we are not getting everywhere catching fire. Nitrogen is an inert gas. So nitrogen is very stable in the atmosphere. Okay, that is protecting our environment. If you see nitrogen is there, oxygen is there, that is actually a livable place. If only oxygen is present, what would have been occurred? If you are firing a match, everything would have been burnt. So nitrogen is one of the protecting layer, and also many of the chemicals and enzymes, what are the things, food, everything is preserved because most of the gas, atmospheric gas is nitrogen. If more oxygen is there, everything would have been degraded. By the time when I am using, within 6 months, my laptop, my pen, my rubber, plastic, everything will be oxidized with oxygen. So nitrogen is more, so everything we are keeping in open space and working. Okay, so we are not keeping everything inside a glass box and working. So nitrogen is one of the important thing, keeping material safe. So you should understand. With respect to nitrogen, all other compounds of stability are given in the Frost diagram. So let us see who is this very stable species in the diagram. You see the stable species in the gaseous form, nitrogen is highly stable. That is what 78% nitrogen in atmosphere, very long time. After that, actually formation of earth, we tell the age of the earth. You know what is the age of the earth? What is your age? You know what is the age of the earth? About 4.5 billion years. 4.5 billion years. So that is the age of the earth. What is the age of the human being? If you ask me, roughly 1.6 billion years only. Okay, the human beings, Homo erectus, Homo sapiens, they came to the earth around 1.6 million years. From that year, we know that actually nitrogen is there in the atmosphere because we have the data after the knowledge of the human being. Around 1 million years, we know nitrogen is there in the atmosphere. So N2 is there. Still date nitrogen is there. So, but who is very stable in the diagram? You see, N2 is one of the stable because that you see that it is in the valley. Again, if you convert into salt, NH4 plus is more stable. Okay, if you have ammonia gas, you know ammonia gas in the laboratory, you may feel that ammonia gas, the punch and smell of ammonia gas. Why you are feeling? Which is not stable inside the bottle. If you are opening the lid, which is spreading inside the room, giving a pungent smell to all. Okay, ammonia gas is not stable, but ammonium chloride salt, if you keep in the lab, it will be more stable because which is laying in the low. If it's laying in the low, what is the meaning? Ne value correspond to, what is that actually corresponded to this delta G by F. So that is what we told earlier, which is nothing but this y-axis representing delta G value minus delta G value. So you are seeing this actually the species is actually laying in the bottom is more stable. So this is what the information you see from this diagram. So now some other diagram I want to show you same thing, same nitrogen. Okay, I told here nitrogen in acidic medium, nitrogen in basic medium I am showing. What is that nitrogen in basic medium? Look at that, what is the nitrogen in basic medium? You will be getting ammonia. Ammonia is a base, you know. So nitrogen in basic medium, you will get ammonia also. So where ammonia is there, I was just talking. Ammonia is somewhere in the higher place. Nitrogen N2 is present in the bottom. See that in the basic medium, N2 only stable, not ammonia. So ammonia bottle, if you are keeping it open, what happened? Ammonia is going out. Nitric acid is not going much in the atmosphere, but ammonia, if you open, it will go. Okay, because stability is less. If somebody is laying above in the curve, they are less stable. If somebody is laying down in the curve, they are actually more stable. So what is the basic? Let us discuss that in detail. So what we do really get from Frost diagram, the most stable oxidation state, because of the Ne is corresponding to the delta G value. So from the delta G value, we are seeing that most stable species, because if you go up, the E value is more positive. So E value more positive means what? If E value is E0 value is equal to positive, the species will undergo spontaneous reaction because delta G is negative. So when you go up, the delta G will be more negative. So that species will readily react. So it is not stable. It readily react means which is actually very easy to react or convert. But the species, the bottom will be having E value is negative. Okay, E value is negative means delta G will not be positive. So which are the species E value is negative? So we can store it for long time. Okay, delta G is going to be 0 or negative positive. So this species is not easily undergoing changes. Okay, unless you are having catalyst or any forceful condition. So the species laying in the low in the curve Frost diagram is the most stable oxidation state. Relatively, I'm talking most stable means relatively most stable in this curve. 4 dots are there, 4 species. This one is the most stable. You have to write because this is the lowest one. Okay, then next, if you see the diagram, who is in most stable species? People may get confusion. Only N2. No, I told you N2 value is close to 0 here, Ne value, but minus value is there for NH4. So this is actually more E value negative. Okay, E value negative. So delta G more positive for this species. So the more actually stable species, the most stable species is NH4. The comparatively next species is N2. So the lowest laying species correspond to the most stable oxidation state of the series or the elements. Okay, this is one of the application of the Frost diagram. The second one, it is not end. The slope of line joining, if you see that in the Frost diagram, if you find out the slope of the line joining of a couple. So here a couple in the sense why I am telling here one species 1, here species 2. So this slope I am talking. Okay, this slope I am talking. If I am line joining of this actually slope of this species, what are the information we are getting? If you get from the X and Y axis, so we are getting this information. One is the N value of the species 2. This is N value of 2. This is N value of 1. Here, this is N value N, N and E, NE value of 1, the N and E value of 2. So we are getting this value from this point, touching point in this graph. So this value we are taking, then we can easily calculate the dy by dx, the slope. So the slope value will be NE, the difference between this one, the difference value of NE to NE, okay, this NE2 minus NE1. So you will get actually dy by dx, N2 minus N1. So you will get dy by dx. So E0 value you are getting from this slope. This value is very important to what is that if a diagram is given, we can get a E value of this particular couple. So E0 value of the couple can be identified using a slope. Okay, this is one application we can see the diagram is ready to use in the any kind of situation. So for example, I want to know that whether HNO2 will be converted into NO, nitrous oxide, which is a laughing gas. So HNO2, if available, suddenly in your laboratory HNO2 is there. So HNO2 actually is available, but NO is formed in the laboratory. So when the gas sensor of NO is activated, your laboratory getting alarm. So people see that what is the gas leakage, where from it is coming, whether HNO2 can give the doubt. First of all, you have to analyze that the data from the textbook or reference book. So what we do that, first of all, we know that HNO2 NO possible. So the value of HNO2 gives Ne value 4.4. Okay, so NO the value around 3.4. Okay, Ne is the value of this value, Ne value of this particular graph. If you calculate for the NO, it is 3.4 Ne value. For this actually here for HNO2 it is a 4.4. So the dy by dx you have to calculate 4.4 minus 3.4. So the dy by dx, if you calculate slope, first one 4.4 minus 3.4. Okay, one value coming, no problem. So what is this actually? The difference between the oxidation state 3 minus 2, that is also 1. So you will get a slope value of 1 volt. Okay, so this you are getting positive 1 volt. So this couple conversion is plus 1 volt. So you see that in your laboratory everybody laughing. So the laughing gas is created from HNO2 in the laboratory. The question is coming. So the HNO2 can be decomposed and give a NO. Okay, so it is not possible because it is a plus 1 volt for conversion of NO to HNO2. So NO2 to NO minus 1 volt. So it is not that some of your friends did a misbehavior, not that HNO2 of my laboratory bottle is leaked. Somebody opened that NO2 from other sources cylinder. So the toxic leakage of the gas occurred. So dy by dx is telling that plus 1 volt is coming. So that means conversion of N to NO2 is positive 1 volt. So reverse is negative E. So that reaction is not possible. The laboratory reagent is not producing NO. Somebody else opened by mistake the valve of NO gas. Okay, so that is what I am just telling, the E equal to 1. So this is one of the application. Just I am telling for a joke actually one of the event, but I am telling that from any couple we can identify the E0 value immediately by seeing the Frost diagram. Even you don't know the E0 value reported in literature by drawing. For example, N2, N2O. How it is possible? You take as a homework. N2 need to be converted to N2O. Whether it is possible? N2 can be converted into N2O because N2 is stable comparable to N2O. How much the E value is required? If the E value is more positive, okay, the reaction will be favorable. So now you have to calculate and identify. So now identifying which is the strong or weak oxidizing agent. That another question can come in the exam. There are two reagents we are giving. So that reagent is HNO3. One is HNO3. So HNO3 is one reagent. I'm giving NO. So I have a doubt asking you which one is a strong oxidizing agent, HNO2 or NO? So now we are having a Frost diagram in front of you. This is a Frost diagram. So I have drawn a extrapolated curve. HNO2 will be having this value from the graph giving plus 6.2. So the NO is giving from this graph, the value is plus 3.4. volt. So now we know this value. So +2 is the oxidation state for NO, +5 is the oxidation state. Now who is actually a strong and weak oxidizing agent? How to know? By seeing the number, if you see from the graph, +6.2, +3.4, from that you don't take any decision because it is misleading information because we are having oxidation state is different. So how to resolve this? First to write the equation. HNO3 is if it is actually converted into N2, which has Ne value 6.2, which is represent to N equal to +5. For only E, if I want to know, E equal to 6.5 divided by 5. So that is what we are calculating. So this value 1.24 is coming from the plus 1.24 is coming from where 6.2 divided by 5. Okay, so the value is 1.24. But in the case of NO is converted to N2, Ne value is +3.4 from the Frost diagram. N equal to 2. So the E value is actually here. The E value is nothing but 1.7. Okay, so now we are seeing that plus 1.7. So this two system, if you look at the two system, by seeing this value, don't take any decision. Okay, this value is actually Ne value because how many electrons are there, that is multiplied. Now only we want to know the E value of the particular case and E value. If E value of this system and E value of this system we know, then we are able to take a decision. Higher the E value, E0 value, that system is going to be stronger comparatively. So now in this case, E0 value of NO is having E0 value plus 1.70 volt. So this is actually stronger. So by keeping in mind that which one is a stronger reagent. So if you want to know from the Frost diagram, we can say NO is a strong oxidizing agent than HNO3. Okay, so these are the information we can easily decode because we know that Ne versus N only there. So now it is actually another important thing I want to ask you. There are the slope, the curve is having different trend. Okay, so who is going to have actually higher capacity for reduction potential? Okay, if you understand the slope is different, you see in the case one here, the lower the reduction potential. If the slope is like that, so the reduction potential is lower. If the slope is deep, as in the case previously asked N2 to NO2, you see the slope N2 to NO2. So the slope is very steep. If the slope is steep, so you see the higher reduction potential. What is the implication of knowing this term? So the species, if you are seeing that after getting the slope lower the reduction potential. So the lower lying species will undergo oxidation. If there is a slope, you see that the lower lying species, this one is undergoing reduction. Okay, I am writing or. So if you are having a slope, you are calculating a steep slope is there. The species sitting in the top, which undergo reduction. Okay, this undergo oxidation. So this undergo oxidation, lower species, the higher species undergo reduction. So from the slope value, we can see the slope value, we have to see E value, how much is coming. Accordingly, moderate, strong, weak, we can predict. Okay, so low lying species, oxidation, high lying species, reduction. So both are having slope, but we have to see the E value. So now I want to ask you, disproportionation can be told from the Frost diagram. So if you see that just Latimer diagram, you can tell because Latimer diagram I already taught you. If you see that right hand side potential is more than left hand side, for example, NO. In case of NO, you take the right hand side potential is more positive. Okay, right hand side is greater than left hand side. So the NO is supposed to undergo disproportionation. Okay, so which are the species will undergo disproportionation in the Latimer diagram? You can easily say that N2O4, NO, NH2, OH, because here also this is having more positive E value, this is negative. So this also will undergo disproportionation these three species by Latimer diagram. The Frost diagram, do you have any clue from the Frost diagram? This is my query. The Frost diagram also you can able to produce. Okay, we can see. The species which is laying above the line joining of two species will undergo disproportionation. This is very, very important. Here this species, particular species is laying above the line joining of these two species. That is what in the exam you have to use the graph sheet, or in the assignment you have to use the graph sheet to draw the Frost diagram, because that is very important. The line joining you have to draw using scale. When using that, you see the line joining showing that this is laying above. That means with respect to this particular species I put across, this star, or you keep it a star, this species is having the delta G value is more negative. So this will be undergoing disproportionation. Disproportionation means converting into two species. One have higher delta G, one is having lower delta G. So this species undergoing the disproportionation, because with why it is undergoing disproportionation, if you see the curve you will be getting confused. Sir, this is in the top. Oh, sir, this is more stable than this. How it will undergo? Not like that. We have to see this way. You see above the line joining of these two curve, one species sitting above this line joining. So at the average, it is higher. So that is what it which is undergoing decomposition. The rate of converting this is more than rate of converting. The rate may not be 50-50. The rate will be more here because this species is having more favorable than this, but the decomposition will occur. That is the beauty the Frost diagram can tell about disproportionation. Now you see the curve, but I told this curve is typically I have written actually from, but now you see in this curve it is very clear, no confusion. Okay, this is the line joining above sitting, line joining above sitting. I put actually nitrogen in acid and basic condition, acidic and basic. This is acidic condition, red color I put it acidic condition. Okay, nitrogen in acidic condition. The bottom one is actually I have put basic condition, nitrogen in basic condition. So now you see this both, you are seeing this species which are sitting in the above, which undergo disproportionation into the two species. Okay, this also will undergo disproportionation. This will undergo, easy to mark. Here also this will undergo disproportionation. But here you have to carefully draw the curve and make a line joining and tell. That is what in the exam I will not give this kind of question. I will give at least clear question to you. So these all the things will undergo disproportionation. Okay. So in the Latimer diagram, you need to check that E value of right hand side, left hand side. The Frost diagram, nothing can be told. Whenever there is a hump is there, we will say this is undergoing disproportionation to two species. So this species one is doing into 2 and 3. That is what we are going to, because it is above the line joining. What is the reason logic you have to say? Because the average delta G. So the average delta G value of this line joining above species is higher than these two. So that is what we are telling, which is above the line joining of these two species, so which undergo disproportionation. This is the logic normally told. You see that this average, if you see for this species, if you draw the line joining of these two species, this is laying above. That is the meaning. Okay. So now you see disproportionation, identify disproportionating species in this acidic and basic medium of oxygen molecule. This is in acidic, this is in basic. So you can easily see the line joining above, this species is there. So this will undergo disproportionation. Here if you do line joining of these two species, this is there. So HO2 minus will undergo disproportionation. Hydrogen peroxide also will undergo disproportionation. So that is what I told the last class, hydrogen peroxide undergo disproportionation because the line joining of water and O2. What is remaining in your bottle? I told yesterday, water will be more because water is more stable than oxygen, because line joining, if you see, water is having more delta G. So at the end, hydrogen peroxide you are buying in the market, you are having water in your bottle. So this is what I told, because the stability based on the Ne value of Frost diagram, if you know, then you can able to predict the two species will undergo disproportionation. So come proportionation. Come on guys, you may be having a doubt actually, sir, disproportionation, you told what is called come proportionation. It is a reverse. One species getting into two species, that is called a disproportionation. Okay, so one is converted into two, that is disproportionation. Come proportionation means two species supposed to give one species. Okay, this is the way they are joining and forming a new species, that is come proportionation. Let us see. Here you see the species 1, 2, 3, 4. 4 species are there. I am marking the 2 and 4. They are giving a new species because it is falling below the line joining. This is the line joining I have drawn. You follow this line. Below the line joining, the species is, this particular species is present. So this is a come proportionated species according to the Frost diagram. Easily you can say this, immediately you can put an arrow. This is come proportionation. Now in the diagram you see, because the disproportionation pehle dekha, now you see that the come proportionation, which are the species. Easily you can say first here, okay, which is below the line joining of these two species. Okay, this one, very good. You can say here, yes, we can say If it is slightly below this, we can say, again, you can say some of the species are marked. This species, very easily you can say, okay, NH2OH, NO, this N2 species with respect to these two blue color lines you follow, N2 will be disproportionating. And again here NO2, easily one can say, because with line joining easily it is in the valley. Okay, this will undergo disproportionation. So that is what I am marking. These are the species will undergo disproportionation. Even this species also you have to mark it. It is not
So
shown. Yes.
I have a doubt. So will NH2OH and N2O
No, no, this is disproportionation. This is
disproportionate to
disproportionate.
N2 or NH2OH and NO? Because you made the arrow from NO. Is it only
Sorry,
for the two consecutive
there
ones?
is, sorry. This is disproportionation only. I just marked it. Come proportionation you tell now. Come proportionation NO. NO is come propor. This disproportionation is only I told. Now when I am spelling out disproportionation, I told. Okay. So this is disproportionation. You use come proportionation. Sorry, this is the wrong actually. Come proportionation means this species and this species will form NO. Okay. Come proportionation, disproportionation. What is the difference? Come proportion. Sorry, you see the disproportionation. I will show you. Disproportionation means one species is getting converted into two species. Put an arrow like that. Okay, this one species, species one converted into two and three. Okay, so product is two products. That is called a disproportionation. Come proportionation, we supposed to get only one product. Okay, so two species combining and giving one product. If there's any confusion, so I have confused you. I will just show you. In the come proportionation, the two species is forming one species. Sorry. The species 2 and the species 4 is there. The both are giving the species 3. Okay. This is come proportionation. Is it okay? Now we go to the diagram and see which are the things are forming come proportionation. You remember this one, low lying. So now you tell me which are the things low lying. I rightly told actually what is the confusion, I don't know. Now you ask me which one you are telling.
Sir, actually you made the arrow for proportionation from NH2OH and other from NO. So my doubt was, will it be from NO to N2 or N2O to N2? Like one is NH2OH and N2O converting to N2, and other possibility is NH2OH and
Yes.
NO converting to
No, no, no.
N2.
I ignored that N2O2. It will go if you write, if you consider N2O2, N2O2 will give N2, N2O2 and NH2OH. This and this species will give N2, right?
Oh, yes, sir.
In case you are not having the species, I am only giving NO and NH2OH. Okay, that will not form. That is what I am telling. So I have missed out this one to circle it properly. So I put an arrow here because this is the species 2. This is species 1. Okay, this species 1 and 2 giving the my product 3. Okay, so 1 and 2 together giving 3. How to know? It is not just actually giving a guesswork. We have to write the equation and prove that. How to prove that? You have to write a full equation. NH2OH. You have to write a full equation like that. NH2OH plus N2O gives N2. Now we have to balance the equation, okay, with the electrons and all. Then we have to tell. I will show you some example, then you will come to know. Okay, it is not just telling that actually two species will give one species will go two species. We have to write the equation and tell. Last class I told disproportionation or comproportionation. You have to calculate the E value and to prove. This is guesswork from the diagram trend of the curve we are telling, but we have to show again which will undergo come proportionation. Now actually this is come proportionation only. Here NO gives NO2 minus and N2O4. So these two species together, they both combine and give this species. This is what happening for the particular system. So I will show you this is that the come proportionation reaction. If you say N to NO, that your question is answered here. Your question NO and NH2OH can give a N2. This question is there. Not balanced because N2O will not be formed. In this case, N2O will not be formed. If I am asking this, it will be formed, not balanced. Now, if you want to have a balanced reaction, you have to write N2O4 reacting with the 2 electron and giving NO2 minus. So NO react giving NO2. So then the 2 electron and the 2 electron we cancel, oxidation and reduction reaction, write the net reaction. If you say example, if you want to get to NO2 minus, okay, where is the NO2 minus? This one, the case 2 I have written. NO2 minus, the NO and N2O2, N2O4 supposed to combine. So the reaction, we have to write a two redox reaction. What are the two redox reaction we are writing? N2O4 to NO2 minus. So you have to carefully see N2O4, NO2 minus, one reaction I am writing. The second reaction is NO and N2O2. The second reaction is NO. So this is the reaction 1 I am writing. This is reaction 2. These two reaction we have to write. Okay, one is, this one is conversion is what? N2O4 to NO2. What is the reaction? This reaction I have written redox. Two reduction reaction N2O4 to NO2 is a reduction reaction because adding electron. So NO2 N2O4 is actually oxidizing reaction, oxidation reaction which gives electron. So after solving one reduction reaction, okay, reduction oxidation reaction. So then we can combine the reaction. We will get NO N2O4 in basic medium because of actually solving the oxygen molecule, because water we are writing to balance that proton we are adding. Okay, because here 2 water molecule, 4 water molecule, 6 water molecule is required. N2O2, if you are writing 4 water molecule, 4 oxygen is solved. Here 2 oxygen need to be solved. So 2 water molecule. So 2 means 4 OH we need to add. So 4 OH we have added. So it is not the simply these two only giving. The medium is important. This decomproportionation occurring in the basic medium. So that we have to remember. It is not the two species directly forming. That is not. That is a medium is required. So 4 OH minus we are giving. So this is a balanced reaction. So the condition here, if you see, this is N2 in the basic medium. You have to remember that this is in the basic medium. You have to remember in mind. So N2O4 and NO can combine in basic medium, can give a NO2 minus. So this is what I have written in the balanced reaction. You have to write, then only you can say this is actually a comproportionation reaction. Then if you calculate the E value, you will get a E value also for this favorable reaction. E value is equal to positive, then the reaction will occur. Okay, you have to calculate the E value. That is assignment I am giving. You have to calculate the E value for formation of NH2OH to N2O. Okay, NH2OH and N2O giving nitrogen. This is the one set you have to calculate for the E value. Second set, NO2 minus. This is second set. These two set you calculate the E value and verify comproportionation. That is a homework for you. So I will, when I am sharing the slide, I will write it there. You have to just go through. It's not for tomorrow's assignment, but you have to go through. Okay. So now I am summarizing within 1 minute because I have to conclude the class. So I will give one more homework. If I am giving M1O4 in basic medium, M1O4 minus. So M1O4 minus I am giving in basic medium. How the permanganate in basic medium, how it will be undergoing different changes. So I am giving the Latimer diagram. You have to draw the Frost diagram for the set. So for acidic medium, I will give you a model Frost diagram. For actually this basic medium, you have to draw the Frost diagram for basic medium. I will share the slide. That time I will mention this is the third homework. Second homework I told, first and second homework I already told. These two systems. Comproportionation system. This is homework 1. This is homework 2. Okay, you have to calculate it. So now I will summarize that what are the things we have seen, which is the most stable species in the diagram. The species which is very laying in the low, which is more stable. The lower reduction, comparing the slopes of the two systems, low reduction potential, high reduction potential. If you are having the slope of the lower reduction potential, the low lying species is oxidation, which undergo oxidation. Okay, undergo oxidation means which is a reducing species. You have to remember that the species liable to undergo oxidation means this species is called a reducing species, reducing agent. So now the species in the slope is positive, the species laying above, which is liable to undergo reduction. That means which is a oxidizing agent. So this question confusion will come to the students, which is called a reducing agent, which is called oxidizing agent. The above laying is called undergo reduction. So it is an oxidizing agent. So which is disproportionation means the species which is laying above the line joining of two adjacent species that you remember, which will undergo disproportionation. So I write it this. So which is the species which is laying below the line joining of two species, adjacent species, which is nothing but formation is come proportionation, COMP. Sorry. So now you have the 5 conditions you note down. So for the permanganate system, I will be giving you homework. You have to identify stable species, strong oxidizing agent, strong reducing agent, all the things you have to count for permanganate system. That is the homework I am going to give you. Okay, people should actually try to do the homework, and then actually then only you can able to know perform well in your test or exam. So I request you people to do that. Solving the problem or homework always you do. Okay, so students, thank you. So I have taken the attendance. You people can